Hello everyone and welcome to another episode of Automation with atmega32 series of video tutorials. And like I said in the earlier video, today we are going to be doing our first ever project, which is going to be about turning LED on and off. And for us to do that, actually we'll need two of the tools that we talked about in the earlier videos, and this is going to be this tool over here, proteus. Just going to open it and WinAVR, because we'll need it as a compiler. We are actually going to do it in a virtual environment, and then later on we'll do it with a physical hardware, physical chip, the real atmega32 chip. But for today, everything is going to be done in a virtual environment with a virtual hardware. So let's just open a new project. Once you open Proteus, this looks like. Now it takes a little bit of time to load, and this is what we have after loading our new project. We can change our project name as LED Blink. You can name it, however, LED Blink, and then once again you can save it anywhere in your PC. The default folder for saving is always actually in the document, but I already set up a folder for that, and it should be somewhere in desktop. Okay, where is our desktop? It should be somewhere in desktop. Can't find. Okay, it is. Once we've selected the folder, we can just go ahead and click next. We are going to leave this one as it is because we'll need a schematic where we'll draw a circuit. Then just click next. Then this one also we'll need to keep it as it is, because we don't really need to have a PCB layout at this point. So we just go ahead and click next. The next window that shows up is for firmware. We are actually going to need a firmware for this because we are going to code and give instruction to a microcontroller to blink an LED. So let's just click. Then the family is AVR. Actually, atmega32 belongs to AVR. Then controller, we are going to pick atmega32. Is it atmega32 or atmega32? Actually, potato, they all sound the same. So then this is where, as a compiler, we are going to use WinAVR. Very important. This is why I said it will be very important to install WinAVR, because it's used here to compile our project, our code, so to speak. Then just click next, and then finish. It will take a little bit of time, but we have it. Once it's done, we are going to end up with two tabs, one for firmware for writing our code, an editor sort of, and another tab would be for schematic. If you look at it, we have a skeleton code over here that we can just edit, but I'm going to start everything from scratch, so I'll delete everything here, but let's just set up the schematic part. I'm going to expand this so that you can have a view of what we have here. Now this is atmega32, and you remember we spoke about the pins and how it's set up. So we have port A, port B, port C, and for this for LED blink project, I'm actually going to use port B, pin B0. So I'm going to connect our LED to pin B0. To do this, we are going to select LED from component library. To access component library, the left part of the screen we have letter P, and then just go to letter P over here and left click it. Then there is a search box here. Just type in LED and a library of components will show up, and with so many components to choose from. The LED that we are going to go for is actually animated, not bi-colored but single colored animated LED model. Let me go with blue for now and just click OK, select it. Then with your cursor inside the workspace, just left click inside the workspace and your LED will be placed. Left click again. Okay, to work with LED, actually we'll need a current limiting resistor. This is very important, because if you don't include this, LED is going to be choked, to be scorched, or to burn out because of excessive current. So let's just go and pick a resistor. 200 ohm resistor will be okay. Left click the letter P and then type resistor. This is what is wonderful with proteus. It always gives you a number of the components you've set. It's going to give you multiple options. So I'm going with 200 ohm resistor. So anything above 200 ohm should be okay. I'm going to find it. It takes a little bit. Let's just scroll down. There I have it, 200 ohm resistor. Then select it. Click OK with your cursor and within the workspace. Then just left click. And we have our resistor. We can actually rotate it. Right click. Then rotate clockwise. Now we can connect. This is the positive end of our LED to pin B0. Actually, if it's becoming hard to connect, you can toggle the grid. You can either have the grids. I prefer not to have the grids, but if let's just do some connection now. These are the bottommost end of the resistor should be grounded, connected to 0 volts. So to do that, we have the left part of the screen. We are going to where we have terminal modes. Just left click it and select ground. And bring your ground. Now we've connected. Actually, now we are done with the schematic part. We can save. So let's go to the coding part. I'm actually going to do away with all this. So that's actually not everything. The include fields. The first and foremost, what we have to do is include libraries, important libraries. These are we include, in the earlier videos, I already told you that if you don't have the basic knowledge of C or C++ programming, I really stress that it would be important for you to go through it first and find a tutorial where we have basic, just the basic, where you are going to familiarize yourself with the basics of C or C++ programming. And if you've already done that, then I'm sure you know what I'm doing here. What I'm doing here is including a very important library, and not really that should we include this should AVR here that it's these are very important library. These are for all atmega, for all atmen family of microcontrollers. This is always, if I come to think of it, is like for you to do anything, AVRIO.h library is going to really come in handy. You can't do anything without this library. It defines all input-output functions of atmega microcontroller chip. I'd like to think of it as a toolbox. You can't do anything without a toolbox. And this library contains all those functions that define the registers or the input-output functions. So it always has to be the number one library to be included. Then we are going to blink LED. That means it's going to be on for some time and then off for some time. So we are going to delay. It's going to be on, we delay, and then we switch it off, then we delay it when it's off, then switch it on back again. So another library will be needed, and that okay. This should be okay. Now this library, okay, it's going to provide our code with all the delay functions. Like if you are going to delay every instance of delay, like for if you are going to delay you are off for 1 second, then you need functions to perform that, and they are contained in this delay.h actually. Now, okay, so what we're going to do now is jump straight, because we've done LED blinking is actually a simple project, and we are only going to use these two libraries, so we can jump straight to int main, which is always the main routine int main function, and this is where we define our let's just I'm going to describe it in pseudocode. Whenever you see a double slash, what follows next are always called pseudocode. These are statements that are human readable, that you can actually read and understand. Having a double slash means that we are commenting them out, so that when the compiler is compiling our code, it's going to it's never going to see these statements. It's going to bypass it. What we're going to do is to, since our LEDs are connected to pin B0 of port B, we are going to set pin B0 as output. Set pin B0 as output. Then we need a pin status. Pin status will always we are going to tell the microcontroller that the pin that we are working with is either low, which is 0 volt, or high. So that I'd prefer to work, I prefer for this at the start, our pin B0 to be at 0 volt. So we're going to set it low. Set pin B0 pin B0 as low. That means 0 volts at the beginning. Now these are pseudocodes. These are they actually help us structure the code and understand what we are doing. So to do this, okay, let's just do the pseudocode first, and then we'll get to a point where we are going to write our code. So the while one loop, actually what I failed to mention is just for Arduino lovers, for Arduino followers, this one is always denoted as void. Then we are going to set our pin B0 as 0. set up anything inside these functions get to be executed once the microcontroller is powered on. This is always where the code starts from. Now, okay, and then these are just to be mindful of Arduino followers if they are in here. This one is always denoted as void. Function. This one is always a never-ending loop, and actually Arduino uses so much of C++. While what we are going to be doing here is mostly based on C, but actually C and C++ are actually interrelated, so there'll be no harm doing it either way. So let's just move on. I'm going to describe here what we'll have in while one. While one loop is actually a never-ending loop. That means the line of codes, the instruction inside while one loop, executed from the first instruction to the next, and then to the last. Then after the last, it again goes back to the first, and the cycle repeats itself endlessly. So it's while one loop. So let's just say that here we'll turn on the LED, turn LED on. Then delay it for some time. Delay on status for some time. Then again turn it off, turn LED off. Sorry, this normally happens to me. Turn LED off. And then again we are going to delay off for some time. What am I doing? For some time. So this is what we're going to do inside while one loop that is going to be executed inside the loop. It will turn LED on, turn it, delay it. It will execute it from turn LED on all the way to delay off for some time, and then the cycle. Then it will go back to turning it on, and the cycle goes on and on and on and on until you unpower the microcontroller. So it's a never-ending loop. So as we go down the road, we are going to work with functions that we can declare outside the main routine, and then we do a function call inside the while one loop. That's how we get to perform anything outside while one loop. And also we are going to talk on interrupts. So that's also a key area that we're going to consider. So let's just let's begin with the, where do we begin? Let's start the low-hanging fruit. This one, we are actually, to set pin B0 as output, we are going to use what we a register called data direction register. On DDR, data direction register on port B. That's why we have B. If it were port A, we could just have A here. But we have a LED on port A, pin B0, so data direction register on port B. Then we are going to do a bitwise OR and parenthesis 1 shifted to the left, pin B0. There's a number of ways to another way to do it is in binary form, where we can in binary form we can have it as 0B, and we are 0 0 0 0. This is another way to set it as here we have DDRB. Let's just comment this out. Is another way to do it, or we can also do it in hexadecimal format as DDRB equals to 0x. Actually, it's lowercase x 0 1. This one takes the hexadecimal format. This one takes binary format. Okay, I think that's done with setting pin B0 as output. And now, since to set it low so that when you power the microcontroller, it's going to be, the LED is going to be off. We use another register called port B. It's port B, and this is the way to set it as low. Pin B0. Similarly, this format applies. And now, I think that's done for setting up our pin B0 as output, and it's now pulled low. So the next thing we are going to do is to turn the LED on, and this is how we do it, port B. Okay. One shifted to the left. Okay, pin B0. And delay for some time. To delay, underscore, then delay. Don't worry about these are just functions that are found inside some of these libraries. Like you don't really need to worry about. You just need to master them and their functions, their use, how they are used, and even such operations as setting ports and pins as output or input. You just need to master how it's done and what they are used for. You don't actually have to strain so much into wanting to understand actually what how they came to be. But now back to our delay, then millisecond. I missed that we are delaying in terms of milliseconds. Now let's have a 200 millisecond delay for now. A 200 millisecond delay. Then let's turn it off. What am I doing? Port B. Shift to the left. Sorry, excuse me. Okay, what do we have here? Pin B0. And already I think you can now see that we have a pattern over here. And the last bit of it is delay. Okay, we are going to delay off for the same amount of time. Control C to copy, and then Control V to paste. So just a recap of what we've done here, and believe it or not, our code is actually done with. And now just a recap, we have included AVR, io.h. This one defines the IO, the input-output functions of a microcontroller. Then we've also included the library for delay functions. Then inside our main loop, we've actually there is no need for this because I already have included the pseudocodes. Like I said, the pseudocodes are human readable statements that you can read and understand. Then now our code is done. We are going to blink our LED, and we are going to make it blink on and off at with a delay of 200 milliseconds between on and off. And once it's done, just to the left part of the screen where we have source files and then main.c, you can see at main.c we have a star. That is because we haven't saved our project, our code. So we just click on the save icon. It's saved. Now we can build or compile our project. Just go to source files and right click. Then come down to build project. Then below our screen we'll see our project compiling. It's compiling, and you can see it's compiled successfully. So when it's compiled successfully, we can run our simulation. Below, just bottom left, we have icons for running simulations, for stopping simulation. Just we have the play button, the bottom most left icon. Just left click it, and it will take us to schematic, where it's going to simulate LED blink, and you can see our LEDs blinking on and off at the rate of 200 milliseconds. We have our LED blinking, and that's our first project, LED blinking. So we can play around with our code actually, and let's just increase the blinking time to 1 second. That is 1000 milliseconds. I'm just going to increase it to 1 second. Then save it. Go to source files, build project. It's compiling, and it's compiled successfully. So, and just run the simulation, and it's easy to notice that now the blinking time is long. It's actually not the same with when we have it blinking at 200 milliseconds. So another thing we can do is actually what I want to do now is to keep it on for long and off for a short period of time. On for 1 second and off for 100 milliseconds. Yes, and build the project. Run simulation, and we'll see what happens. You see it's off for a short period of time. And that's all about LED blink. This is interesting, isn't it? And this is just the first project that we're going to do, the most basic. And actually, if it works here, if you leave this